I am Jubair Mustafa. Now I am going to demonstrate a buffer overflow attack. Here I have written a code where the logic is simple. I have a login function which have a password array. This is our buffer and 16 size. So if we take input from user and compare input with this is my name. So with this input, with the input we check with Jubair, and if that is correct, then if that is not correct, then we print this, and if that is correct, then we call the user function and converts as user logged in. So how we can exploit our buffer? This is our buffer. This is store value in stack, since we declare this array within a function. This take memory address from stack. So open terminal. First of all, we need to check whether our memory randomization is running or not. If memory randomization process is running, then we cannot exploit our memory. So checking command, to check command, cat process system kernel randomization. This is 0. If you get 2, then you can simply type echo 0 with sudo t command process system kernel randomization, then give your password, and this will be 0. And we have to check our resource limit. You limit, see this is 0, but we set this unlimited. Yeah. Now we run our program with this command gcc -o vulnerable fno stack protector with memory 32 and code. So this is gonna get executable file, and if we run our program vulnerable, then enter password, we input a random input like a incorrect password. If we input Jubair, then it's called the user function and converts the user. Now we are going to our debugging mode, gdb vulnerable. Now if we run in debugging mode our program, then it's normally executed normally. So how about memory addresses? Now we look into our memory by disassemble main. If we look our code, so first this is main function, this is login, this is user. So if we disassemble our main function, there is a call to login function, and this is the login memory starting point. The same way, if we disassemble our login, then we can see our stack pointer. This is the stack where the 16 byte started, and this is our printf function, scanf function, str and compare function, and this is our printf and user calling function. And if we disassemble our user function, this has to printf call right here and here. So this is the memory overview. If we do not explain all of the short term here, just stack pointer, this is ESP means stack pointer, and this is base pointer, and we will look into forward and see some others necessary memory terms for this tutorial. So now we set breakpoint before stack scanf and after scanf. So like we can set our breakpoint right here by copying the memory address and command break that address, and after our scanf, so we can set memory address right here, break here. So this is this create to debugging pointer is before scanf and after scanf. Now we run our program, and this stop in breakpoint 1 in login function. After that we continue with C command, enter your password. If we input a random input like A and enter, it stop again breakpoint 2, and if we continue, it's provide our incorrect password. So how about memory happens when we run the program? So again we run the program with here you can see I input only 4A because it if we demonstrate with 4A or 8, then we can see our memory easily to understand the scenario. So examine with 20 stack frame from stack pointer, and you see this is the memory address where the buffer is starting, and we write 4A, and this is 41, 41, 41, 41. All this is the ASCII code in hexadecimal format. So if we continue and run again with more A, like 4, 5, 6, 7, 8, and examine with memory with the same command, then you can see this 8 byte here, 4 and 4, 8 byte is overwritten by A. So we're gonna write memory address all of 16 byte. So we get out from the debugging mode and run a Python command, from where we get our input. So print A like 16, and this will execute it normally since our buffer size is 16. So write into a file of missing this, forget about this, and run the command again with okay. So this input text file with 16a, we can output our input file. Get input, yeah. So we will go back to our debugging mode by fg command. So this will provide incorrect password, and look, run again with the input. This stop in breakpoint 1. If we continue, enter your password, and password is given from the input file. So if we look into our memory, examine x from stack pointer, you can see here 1 2 3 4 and 16. This is one of these carry 4 byte, so 16 is overwritten, and we continue. This said exit program normally. So we know to overwrite our stack pointer, we first overwrite our starting point of ESP. We can show you what really happened by info register. Oh, sorry. So if we write command IR, and this is what is happening. This is our next instruction pointer EIP, from where the code will execute next. This is our base pointer, this is our tag pointer. So all of these are 4 bytes, so we need to overwrite 3 into 4 12 byte to completely overwritten our login function, and then we indicate to other function, jump into that and exploit our buffer explosion occur. So we examine ESP, continue, and this is overwritten and program is normal. So go back to terminal mode by Ctrl+Shift+Z, and this time we'll put more text, like 28 times. So 3 into 4, so 16 plus 12 is 28. And go back to our debugging mode, and this will create run our program with txt and continue password, and examine our 20 byte stack pointer. This override all of this. So if we disassemble our login function, we see our user function starting address is 804848B. So we now overwritten our all of the base pointer and return address. Now indicate this address. So the program with a wrong input execute this function. Then continue, and this provide illegal instructions. So basically this exploit our buffer and override our buffer, and we will now exploit with the next instruction pointer. So go back to our terminal mode and create our next instruction pointer with this one right here. So in memory we need to reverse the starting point to execute from there. So hexadecimal format x 8p x 84 and x 04 and x 08. Oh, sorry, this pointer. Yeah. Now, if we output this input text, you can see this is a memory address. So this is a carvers value right here. So this is our debugging mode, and run the program with the input. Assign memory address. This is all okay because till now the scanf function not fixed. So continue. Input is get from input.txt. Now we can again examine pointer. Yeah, and you can see after the memory addresses, that is the starting point what we have written in input txt file, the user function. Yeah, so to continue this output incorrect password because we put 28 times a, not our required input Jubair. It also reject to the user function and print convert Jubair of accessed in your machine. So this is all about our tutorial. If you are interested enough to if you miss something, then you can go to my GitHub place, and you can find all of the command necessary to exploit the buffer. So thank you.